All right, we are live. We'll give everyone a couple more minutes to filter in. Um, if you would like to keep up with future events on this channel, you can check Anant.us/events. We have another webinar from me coming up later this week on distributed machine learning frameworks, and then also two by my coworker Arvind Patel next week. Um, And like I said, you can keep up with those at anant.us/events. Um, you can get started probably around 10:32, just giving people time to filter in. And I'll start with a little, well, the introduction of the topic, and then basically ground rules for if you have questions during the presentation. All right, I believe we are good on time. So welcome to today's webinar. Today we'll be discussing Spark and data lakes. This is part of a series on Apache Spark companion technologies based on the Databricks platform. So what we did essentially in part one was we looked at some of the features of Databricks, which is a managed version of Apache Spark, an upgrade potentially even, since it's made by the same people and has extra features. But it also, as part of its wider platform, has a bunch of technologies that it connects to. Um, and so our first part of this series was an overview of those. The second part, we talked about notebooks, and today we're going to be talking about data lakes. My name is Obi Anunachi. I'm a software developer with Anant Corporation. Um, we do these webinars pretty much twice a month. Well, each twice a month. So there are four at least each month, as well as various other events partnered with DataStax and other um, people that we tend to work with. But you can keep up with all of that at anant.us/events. If you have questions during the course of this presentation, you can put them in the YouTube chat. Um, and I will get to them during the break in the presentation or potentially uh, during whatever we're talking about, or if I don't get to it in either of those places, there will be time at the end. Okay, so starting today, data lakes. Um, so data lakes are they're storage solutions. They're not necessarily in the cloud, but that's mostly what we're going to be talking about today. Um, so you can see at the bottom three examples of cloud data lakes, and on the top right is one that you can install on premise pretty easily. Uh, Cloud providers like Amazon, Microsoft Azure, and Google Cloud offer data lakes. Um, they're very durable, scalable storage. They're all distributed storage systems, which means it stores your data across a number of machines with replicas so that if things go down, you don't lose your data. I believe S3 was advertising a 99.999% reliability or something like that yearly, so very unlikely to lose your data. Generally, data lakes are optimized for storage of raw data, but you can store structured data as well. They're normally conceptualized as either blob storage, which will store arbitrary, sorry, arbitrary binary data, um, key value store, or what do you call it? An actual file system. Um, So depending on, generally they all have the same abilities. Just the conceptual understanding of them will be different depending on who you talk to. They store data in their native format, so whatever you put in, it will store it in that format without changing it, unlike databases, which might shuffle it around to match your schema, drop things that you don't necessarily, that you put in, and interpret your data in ways that you might not necessarily want. Whereas a data lake will store it in whatever format you put it in forever. Um, it doesn't do any of the sort of schema analysis that a database would do when you try to insert data. Some data lakes natively include version backups, so anytime you change a file, um, it will store the old version as well as the new version. And sometimes they have analytics, or at least different payment tiers, um, that sort your data depending on how often you access it, where data that's accessed less often costs less to store. Uh, so generally, um, we've actually got two slides on data lake architecture. This one is actually Hadoop distributed file system, which you saw on the last slide, HDFS. A logo for that was in the last slide. But you can see generally it will store your data with replications and balancing, etc., across a number of data nodes, so that if any particular data node goes down, you still have your data. And then it retrieves that data for you based on metadata, whether that's names or other data. And it even looks like it has a secondary name node, so that if your name node goes down, you have your file names in backup somewhere so you can still get them even then. And then on the next slide, we have a, this is specifically the architecture for the Azure Data Lake. Well, you don't get to see all the architecture for it, obviously, but the important part that you can see is in the bottom half. It's actually based on Web HDFS. So even cloud data lakes, well, we don't know that for sure about Amazon S3 or Google Cloud platforms, whether or not they're based on HDFS. They do have these distributed file system like integrations. You can interact with them as if they were, but you don't necessarily know if, because they're using architecture that they haven't publicized, whether the underlying architecture actually is that. But either way, you use your HDFS. And Azure Data Lake talks about how it can store unstructured, semi-structured, or structured data. Unstructured data is like raw text, binary files, PDFs, um, images, videos, all that sort of thing. Semi-structured data vaguely has a schema. It can be one that's not entirely kept to, um, or it can be one that has room for arbitrary inclusion. Something like JSON might be semi-structured. And then structured data is something that is fully schema compliant, like literally data that you ripped out of a database. So at Anant, we like to use Cassandra. So one of the things that you could put in that structured data category was if you just ripped your SS tables out of Cassandra. They are definitely fully in the schema that Cassandra expects them to be, and just dump them into your data lake. Um, yes. So, and then the other part, if you look at the top box, is about accessing the data in your data lake. Amazon S3 has their own S3 API, HDFS you can access through their protocol. Um, Azure Data Lake is offering something called USQL as well as access to Spark and other analytics. Um, and then Google Cloud Platform has BigQuery, all of which allow you to either just get data out of your data lake or to actually do more involved querying on data that's inside your data lake. Um, both of which are useful things to do. Um, so before we get into these use cases, I want to talk a little bit about why it's interesting to use data lakes with Apache Spark. Um, well, first, Apache Spark has both semi-structured and unstructured data types. RDDs are not necessarily tied to a specific schema, whereas Spark data frames are indeed tied to a specific schema, making them structured data. And then second, Spark specifically is interesting with data lakes versus Cassandra, like I talked about earlier, where you take your SS tables, which are already on disk, and you dump them into a distributed file system. Spark is, it likes to do a lot of things in memory. So your data frames aren't necessarily on disk file structures. So what you do is you need to turn them into some sort of on disk file structure, like a CSV file, and then store that into into your data lake. And the thing about that is that Spark does distributed processing, which makes it, and it also has a bunch of connectors to other data storage sort of like technologies. So Spark could be a good way to get your data from a bunch of disparate places into your data lake in the first place, as well as for processing data that's in a bunch of different locations, um, potentially several data lakes or several different folders inside a single data lake, um, and getting that out to your other data management tools. Um, so use cases. First use case is archival data storage. So it's for data that you don't need to access very often, but you still need it available to analyze. So if you're feeding it occasionally into a BI tool or occasionally into a machine learning algorithm, um, then having it be in archival data storage and setting up your data lake for that will be good. You can use it for storage of metadata or logs from other systems, as well as backups for other storage solutions, especially if your data lake has the inbuilt version control, where it will, when new updates come in, it will store the old version as well as the new version, which allows you to revert back to an earlier point in time if it becomes necessary. Um, can also act as staging for your data. It's not necessarily unstructured data here, but anytime data comes in, um, if you plan to eventually structure it, like force it to comply with the schema, structure it, clean it, and store it in a traditional database or in Cassandra or in a data warehouse or something like that, or even if you're going to clean it and analyze it to get a training set for machine learning work, or other analytics work, you can stage both the initial data that comes in and then all of the various steps in that processing pipeline, in order to get, say, a branching path where your raw data comes in and you structure it and you clean it, and then it undergoes this step because it's going into a traditional database to feed your e-commerce site, and then it also has to undergo this other step where it goes into machine learning algorithm for training to become a training set. Um, and because data lakes can hold frankly ridiculous amount of data on the like exabyte petabyte level, and scale up to that level without too much work, um, even if you have 200 million data points or something like that, data lakes are a good place to store them. Um, and especially if you're going to need to access pieces of it or the whole thing, um, like walking around with a drive with 200 gigabytes of, actually, that's way too small these days. If you have a terabyte drive full of data, uh, like it's better to just have it in a data lake so you can access it from wherever. Um, And then lastly, it's for data organization and aggregations. So because data lakes can hold a truly prodigious amount of data, they make it a good place to collect data, say, from different parts of your organization, that come in and need to get put all in the same spot. Um, and then part of the way that you keep that from devolving into what's called data swamp, where you just have data haphazardly thrown everywhere and it's basically useless, it's all about your organization. Um, so your file system, files and folders, things like that, however you keep track of it, rather than just tossing all your data in, um, can make it useful for even just having that data organized so you know where to go get it when you're starting analytics tasks, or keeping your similar data together so that even if it comes in from, say, marketing and then also sales, if similar data is coming in from both of those, you can aggregate them together. So for our final portion of today's webinar, we're going to be doing a short demo where we get in Spark a file that is stored in Amazon S3. And where we're going to do that is we're going to set up Spark in a Git pod container and attach to my AWS instance. We need to actually install Spark. So this process is borrowed from a coworker who built it for a webinar on connecting DataStax Astra to Spark, which is managed Apache Cassandra in the cloud. And next week they'll be talking about Databricks connecting to DataStax Astra in case you never want to run your own servers ever again. You can have someone else manage your analytics with Apache Spark with Databricks, and have someone else manage your storage, your database, NoSQL database with Astra. All right, so now that we have installed Spark, we are going to start up our Spark master. We open up the Spark UI. Whenever that loads. There we go. To grab the Spark URL, Spark master URL, sorry, because we need that. So we can start a worker node. Okay. And then what we're going to do is we're going to start the Spark shell on this instance with an extra, which is the AWS Java SDK, which will allow us to attach to S3. So before this, I started an S3 bucket and put in what is possibly the most boring example data set you could put in there, which is the classic iris data set for machine learning, just because I have access to it and it's pretty easy to tell when you are looking at it. And also it's very easy to get. In our original notebook webinar, we took that same data set and loaded it into a data frame. And here we're going to do basically the same thing from a CSV file. We're going to load it into a data frame and then just look at it. But first, analysis of this actual load function. All right, so because we're starting the Spark shell, Spark instance is already up, so spark.read.format CSV is pretty obvious. Option header, because the iris data set has columns at the top for header. If it doesn't, then you will probably have to define what those columns are yourself. We're using infer schema. We could also give it a schema. I think we did that specifically in the notebooks webinar, where we told it what all the columns were. And then we're going to load specifically from S3A. Oh, wait, I forgot a step. going to have to exit here. Whoops. Let's quit. There we go. What we forgot to do is to change the Spark configuration. There we go. We need to, whoops. Rename this, so that is not the correct. This one. I accidentally dragged that way out of place. All right, let's just start that over. That was bad. So what I forgot was to give it the access key to my AWS account. This might make us go over. Hopefully not, though. So essentially what was missing was the access key and the secret key for my AWS account, which they will be shown on screen, but I will be deleting them from the account immediately after this webinar so that viewers do not get free access to my AWS account, which is something that you will probably need to watch out for if this is the way that you're going about accessing your S3 buckets. All right, there we go. Be moving into our Spark folder. Starting the Spark master node. Okay, ports, it should be this one. Okay, there we go, we're good. Actually, we almost forgot again. Spark defaults. Make sure it's a configuration file, not a template. So what we're looking for is I lost some notes. Uh, Here we go. What we are adding is this with our access key ID. And then this with our secret key. And then also this. Okay. Start our Spark master again. Open up the proper port to get the Spark URL. Start the worker node. Oh, forgot. Where's the cursor? .sh. Okay, that took significantly more time than it was supposed to, but it's time to start the Spark shell again. And this time, when we run our get iris.csv from the Spark bucket, runs, and then we can press show in order to indeed confirm that there is data there. It also picked the schema properly. You can see Save length, which is this column. It's been cast as double. ID has been cast as int. Can't see the rest right now, but the rest, the other numeric arguments are also cast as double, and the species is cast as string. So that actually concludes our demo for today. There may be a future one once all of this come together, where we use all these things together in a single machine learning training instance, in the vein of what we did with the Apache Cassandra and Spark for machine learning series. But for now, I will sign off. I've been Obi Anunnaki with Anant Corporation. Remember to check anant.us/events to keep track of any future events coming down the pipeline, and be sure to like, share, and subscribe. since this is on YouTube. And if there are no further questions, which I am not seeing any in chat, but I will give it a moment to update. Okay, if there are no further questions, then I will sign off. This has been Obi Anant with the Anant Corporation. Be sure to keep up with any of our new events coming down the pipeline at Anant.us/